So this question starts with a relatively straightforward equation for the complete combustion of propane in oxygen. There's still a number of things you've got to put in place and be confident with to be able to answer it. You have to know that propane is C3H8. That's about knowing that my easy process best provides help, prop 3. We know that the general formula of an alkane is CnH2n plus 2, so it is C3H8. We also know that complete combustion, we are making carbon dioxide and water, and we do that by reacting the hydrocarbon with oxygen. So what's left is for me to balance. And when I look at combustion of hydrocarbons, I will always balance in the same order. I will go through CHO, carbon, hydrogen, and then oxygen. So in this case, I can see that I've got 3 CO2. I've got 8 hydrogens in propane. So I'm going to get 4 H2O, and that then leaves me with 10 oxygens on the right hand side, which means I need 5 O2. So we then move on. We have got here enthalpy of combustion, data. A slightly different question to what you might normally see. We know that an alkane with N carbons, the enthalpy of combustion is negative 496N plus 202. The enthalpy of combustion for this alkane was calculated to be negative 6650. So you are going to substitute figures in to calculate N. Now, it is straightforward rearrangement of equations. So if I put those in, I can see that actually negative 6650 equals negative 496N plus 202. Rearranging that gives me 496N is 6650 take away 202. So I can then work out that 496N is 6448, which gives me a value of N of 13. Now, it doesn't just want to know the value of N. That's your first mark. It wants to know the formula of the alkane. Again, you have got to remember that the general formula of an alkane is CnH2n plus 2. So we double 13 and add 2, and we get C13H28. And then, one reason other than the use of mean bond enthalpies why a value for the enthalpy of combustion of a liquid alkane is different from the value obtained here. And it's simply down to the fact that the equation is relating to gaseous alkanes, not liquid alkanes. There would be an energy change when it went from a gas to a liquid, which would have an impact. Okay, moving on to a graph drawing task. We've got here some data for methane, ethane, butane and pentane. Propane obviously missing, and that's going to be part of what you do. The first job that you have to do is to plot the 4 points that you have. And it's always worth taking the time to do this very carefully to make sure you're not making very careless, simple errors, which can often happen with graphs. So I put those points in, and I then need to draw my line of best fit. Now, I did this a few times until I got it right. That's often the case, and that's why I would recommend that you do this in pencil and do it quite lightly so you can replace it. It should be one smooth sweeping curve, and that's where you end up. Now, what we want is the expected enthalpy change for propane, and this will be unique to your question. It will need to be read from your graph. In this case, it's going to be negative 50.7. I'm simply reading it directly from what's on my curve of best fit. On to 4.5, and we have got here iso-octane, an important component of petrol. Iso-octane, when it's burned, has an enthalpy change of negative 47.8 kilojoules per gram, and its density is 0.692 grams per centimetre cubed. We've got 1 dm cubed of it. So I've already taken some of the data and highlighted it. I've got density, and I've got my volume, which I've converted to cm cubed. From that, I can work out the mass. Density is mass over volume. Mass is therefore density times volume. So I get 692 grams. Now, what I'm then looking at is the fact that I want kilojoules. And the two pieces of data that I'm going to use here are the negative 47.8 kilojoules per gram and the 692 grams. If I multiply those two together, I end up with kilojoules. And I get my value of 33,100. That's three significant figures because I've been given three significant figures throughout the question, so I can't go any higher than that.